Hey everybody, last two questions from that homework assignment. And here's a picture of teachers doing online education. You see, that's me to the right and my wife there to the left with the big smile on her face. Although I'm going to change this caption from online education to something more realistic that she would say. Here we go. Why don't you use Zoom? Okay, let me tell you why I don't want to use Zoom. I don't feel like learning new stuff. This homebound education stuff is tough, man. I feel bad for you people who I know are procrastinators because I am the ultimate procrastinator. If I'm at school, I am working continuously. I love getting in the car. I hate driving to work, but once I'm at school, there's no distractions. I'm able to get work done. This is a big adjustment for me. So up until today, I've kind of felt like all I'm doing is giving you substitute work. You know, here's something that, so the sub doesn't get upset with you. Um, so this is going to be work. I guess I'm going to have to figure out how to use Zoom. We should have a Zoom class where we all meet. So I'm going to work on that. Trying to change my ways, but it's hard. I got the computer right here. I could be playing Skyrim, killing some dragons right now. Uh, you know, um, I don't know, maybe setting up one of my military games and doing that. Uh, e- Microsoft Solitaire. I'm even broken down and playing Microsoft Solitaire. That's how bored I am right now. But anyway, I like these next two questions because I was like, all right, this is a little more realistic what they ask you on the AP exam. They give you molar solubility, and again, that terminology, molar solubility means we're dealing with saturated solution and we're dealing with KSP, equilibria. And then they ask you for the pH, and first thing I'm noticing, oh wait, there's some OH minus in there. That's going to dissolve. So if I know the OH minus concentration, then I can get the POH. If I know the POH, then I can get the pH. But that's not really what they're doing here. They're giving you the pH. And so we know that if they give you the pH, we can use that to get the H plus concentration. And if we know the H plus concentration, then we can use that to get the OH minus concentration. And then we can use KSP and we can figure out molar solubility. So molar solubility means how much of the stuff is going to dissolve, because this is going to be a Le Chatelier shift to the left. And we can get the molar solubility by getting the iron concentration. All right, so what is our equilibria? Glad you asked. Iron hydroxide, iron 2 hydroxide solid, produces iron 2 plus, plus 2 moles of hydroxide. And so the KSP for this is iron times hydroxide squared. And we know that that comes out to be 8.0 times 10 to the minus 16. And normally you would say, all right, if I'm doing this in terms of solubility, then this is going to be S times 2S quantity squared. But the issue is that we actually do know the OH concentration. We know the pH. And if we know the pH, then we know the OH minus, so we have a common ion effect. So we are dealing with a Le Chatelier shift to the left. So I'm not really worried about this stuff, but I do need it to calculate the solubility of the iron. All right, so let's go ahead and solve this. What are we actually looking for? We're looking for iron concentration, which is KSP times the hydroxide concentration squared. Wow, that is the worst brackets known to mankind. There you go. Sorry. Okay, so I know pH. pH is 13. So pH is equal to 13.00. And if we do 14 minus pH, that'll give us POH. And I'm not going to bother to do the substitution here. That's 1.00 on the POH. So that means the OH minus concentration is 1 times 10 to the negative 1. Let's do that. Let's do Negative log, so we got to do the inverse of that. Let's do 10 to the x. So we do 10 to the -1. Yeah, duh. 0.1. All right, we got it right. So the OH minus concentration we get from the pH. I can substitute that in now. First of all, let's do iron concentration equals 8.0 times 10 to the minus 16 over 0.10 quantity squared. And so this comes out to be 8 exponential negative 16 divided by 0.1 squared equals 8 times 10 to the minus 14. 8.0 times 10 to the minus 14 molar. And yay. Okay, so we got it right. But again, that was, recognizing from the other chapters, from the buffers chapter, and yes, buffers can come back and hurt you on this chapter. Recognizing from KAKB that, if we're dealing with a water system, which this is, it's going to have a pH. There's always some H plus, there's always some OH minus. The water molecules self-ionize, and that's based upon this system of equilibria. So I saw pH, and I thought, all right, POH gives me OH minus concentration, and that's my common ion effect, and I can substitute that in and figure out the ion concentration. The next question, remember I said buffers can come back and hurt you. How do I know this is a buffer solution? Well, quite simply, they use the word buffer in the problem. What's the molar solubility of lead hydroxide in a buffer solution containing equal amounts of ammonia and ammonium? And they give you the KB. Well, equal amounts. So I'm dealing with an equal number of acid, which is the ammonium, and the conjugate base, which is the ammonia. And I know that at that point, where you have equal amounts of each thing, pH is equal to pKa. So on this one, they give me Kb. So if pH plus pOH is equal to 14 and pKa times pKb is equal to 14, we could reason this out and say, all right, Kb is equal to pOH at that equilibrium point. But if you want to go this direction, I mean, we could work it out. But I'm going to go ahead and do it the long, old-fashioned way. All right, if I know Ka, all right, so we know that Kw is equal to Ka times Kb, and Ka is equal to Kw divided by Kb. Then we can substitute in. Kw is constant. Oopsie poopsie. And Kb is given at 1.8 times 10 to the minus 5. So Ka for this is equal to 1 exponential negative 14 divided by 1.8 exponential negative 5. And I get a wrong number because I typed in the wrong number. 1 exponential negative 14 divided by 1.8 exponential negative 5. And I get 5.6 times 10 to the minus 10 for Ka. So pH is going to be equal to the negative log of Ka. So let's see what we get for pH. I get 9.26. So pOH is going to be 14 minus that, which is 4.74. So the OH minus concentration is going to be 10 raised to the negative 4.74. And that comes out to be 1.8 times 10 to the minus 5. Again, if we recognize that pOH is equal to pKb and that we were looking for the OH minus concentration, we could have went directly to what was given right there, 1.8 times 10 to the minus 5. I'm just working it out to show you, you know, I had two philosophies on this. You know, one, I would say, look, you learn one way of doing it, you do it right that way, you do it repetitiously, and that reduces the amount of things that you have to learn in order to solve problems. But, you know, doing it this way and typing in all these numbers, you also run the risk of transposition errors. So, if you can see that connection, that the OH minus concentration was going to be 1.8 times 10 to the minus 5 just by looking at that KB, then you could have justified it and just said that, you know, POH is equal to PKB, therefore OH minus concentration is equal to KB. And they would accept that as documentation on the AP exam. But anyway, I got my OH minus concentration, so now I can do the equilibria part of this, which is KSP is equal to lead times OH minus quantity squared, and we know the OH minus, so we're just going to solve for the lead concentration on this. Pb2 plus equals KSP over OH minus squared. Substitute in, what was my KSP value? 2.8 times 10 to the minus 16. All right, so 2.8 exponential negative 16 divided by 1.8 exponential negative 5 quantity squared. And I get 8.6 times 10 to the minus 7. And we go back and we look, and that's what they got. And so I feel pretty good about myself today. All right, so I hope these videos helped you if you had some struggles with it. I haven't checked everybody's work yet. I'm going to do that today, of course, and take attendance and see what you did on these problems. Again, I'm thinking about how to test things and how to move forward, and as soon as I have a plan, I'll certainly let you know. But thanks for watching. Miss you, and talk to you soon. Bye-bye.